Hi, Mr. Minnick, helping Java students learn about abstract classes. We have a Replit Java program that shows bad style in a way because it combines three classes, actually four classes, in the same file. And that's usually not something a professional would do, but it makes it convenient for this video to work better. So I have four classes separated by these rows of / comments. And the important one, I guess, is main, because that class is the one that has a main method in it that executes when I click the run button here in Replit, repl.it. When I run this, it prints out the output, hi, I'm here in class, and sophomores, finish homework after sports or music practice. Okay, well, hold tight because we're going to be upgrading this program during this video. So please follow along. Hopefully you've been provided this link, if it still exists, that you could access this public example program at this website address where I'm waving my mouse. Okay, well, here we go. Let's step through this and do the walkthrough and understand it. Of the three classes that are typed out above main, the top one, the one at the very top, we're going to call that the parent class. But it's not just a parent class that takes advantage of inheritance in Java. It's an abstract parent class. By putting the keyword abstract in the class header here on the first line of the class definition, the word abstract means that whoever developed and created that class doesn't want anybody to spawn or create or construct or instantiate an object variable that is a model student. It would be sort of like if God existed and God said, this is perfect Adam. I don't want anybody to be perfect, but people have birthmarks and people will have some people will actually be left-handed and some people will be different. And the world will just be like spin-offs of model student. So that's something that in industry we would sometimes do on purpose. So there's the perfect iPhone, but then variations of it for different countries that have different electronics rules on frequencies or different styles of where people store their iPhones. Some countries, people don't have pockets in their jeans. It might be illegal. So we make an iPhone that fits like a shirt pocket size and not a Levi jeans or Lee or Wrangler jean pocket. Okay, so moving on. This is an abstract class. Typically, but it's not required, you would have one or more abstract methods in an abstract class. Well, an abstract method, when it's in a class, is one that has the keyword abstract in between public, typically, and the return data type, in this case, void. So if the keyword abstract is there, that means that that method has no body, or rather implementation to it. Instead, it has this semicolon in this spot right here, and no set of curly braces with code. It's similar to how in an interface, every method that's in an interface must be abstract and therefore have no implementation. But in interfaces, you don't use the keyword abstract. It's just the rule and the way it is, and you don't put the word abstract with methods in interfaces. But this is a class. So in a way, an abstract class is really similar to an interface. But there are other differences, and this is one of the key differences right now that I'll stress. In an abstract class, you can optionally, and typically you do, have interesting methods or even accessors, modifiers, and constructors. Actually, I'm not sure if you're allowed to have constructors. I'll test that later in the video. But I know that you're allowed to have interesting methods in an abstract class, like this attend class method, but it does have a body to it. It does have implementation. Well, it's allowed to because it's not an abstract method. See, the word abstract wasn't there, and that allows it to have a body. And another thing that abstract classes are allowed to have that an interface cannot have, instance variables, also sometimes called properties. So you can have things like age, ammo, or my GPA. Sometimes in classes I use the prefix my. Now in this one I didn't, so I'll just call it GPA, lowercase because it's good style to name things lowercase here. So this is a working example of an abstract class. It has some things that an interface would not. So the question came up, what does making an abstract class get you? You know, why? Oh, very good question. Let's see. By making it abstract, somebody like Steve Jobs, somebody like Bill Gates, somebody like Carly Fiore, or her name, the woman that was in charge of like Hewlett Packard there for a while, the lady that was in charge of Yahoo for a while. So these CEOs, Chief Information Officers, or just legendary entrepreneurs, these people come up with ideas, design ideas, but they don't flesh out all the details. They leave one or more methods to be developed by engineers that are like VPs or like senior engineers down below the power structure. But they're very committed that they want people to do homework. They just don't know how they want various people to do their homework. Some parents have rules, the kid does the homework before they do anything else, like play video games or watch TV. Other parents just put the responsibility on the child and say, just make sure you get your homework done so that you get good grades and we don't get phone calls or emails from teachers. So there's different ways to implement things, but the boss says you have to do homework some way or another. So let's see how sophomores in this theoretical example implement do homework. Because the sophomore class that you see here extends the abstract class model student, we would say that sophomore is a child class of model student because of the keyword extends. We studied that earlier with inheritance. But because model student is abstract, it's a requirement that the sophomore class, somewhere in it, it implements do homework. And if it doesn't, if it were to kick the can down the road a little bit and not put any code there, such as this, then you would put a semicolon there and put the word abstract there, and then make the sophomore class also abstract. Yes, there are times when an abstract class is extended by another abstract class that then requires any child below it to implement the details. Some people, when they die, they pass everything on to their one and only kid, but they don't say what the kid should do with that stuff. They just say, as directed, family farm should be sold off to highest bidder, but whether that bidder is a convenience store or, say, a factory for like semiconductor chips, that's to be determined by, well, people down the field, down the road. George Washington didn't decide how Mount Vernon would be like developed, but he left the trust with his child class. And this is sometimes the right way to do things, but I'm undoing this in my demo because I don't want to make my demo that complicated, where we had an abstract class extend an abstract class. So we're back to this version right now that you see where sophomore does implement do homework, but look, it's interesting. Sophomores finish homework after practice. Hey, look at how the sibling class, freshman, which also extends model student, the abstract parent, the freshman class implements do homework differently. Now, it was a rule that freshmen must implement do homework with something in the body of it. But freshmen, they have such easy homework, at my school district at least, that they always finish it during class time or during like study. Well, actually, they don't have study halls around here, but they find time to do it because it's so trivial and easy. So when we execute this code in some future client program, and we have a new line of code here that I didn't have in the original model student, if I reshoot this video in the future, let's say that Jane is a new freshman. When Jane, I named that class freshman. I should have named it freshman with an A. I'm making that change right now. It makes no sense to have a class named in a plural form. So I named it freshmen. And Jane, when she does homework, when she does a .do homework, as you see, when we run this program, hey Dan, what would you expect to print out when I print out, show you the code from Jane do homework? Not to be confused with Dan.do homework. Well, Jane has such easy worksheets, she finished them during class time. Sophomores, they have to do sports and then they have a lot of homework left. So Jane and Dan both call the same overrided method, polymorphism, many different forms of the method do homework, but implemented differently in these two classes. Well, here's the point. Dan, deep down, is a sophomore. Jane, deep down, was instantiated as a freshman. But they both are referenced, and I sometimes call it cloaking. They both act like they're model students. Their parents think they're model students because as a reference, that's what's on the left of the object variable names Dan and Jane. So in a way, they both look the same in the client program, but deep down, they execute different versions of do homework. Now, yes, you could put the word sophomore here and the word freshman here. And that would get the job done. This program still runs fine and it still prints out the same output. But there are times when you purposely treat everybody the same in, say, an assembly, like everybody should show up on time at an assembly in the auditorium, where a student is a student. And we don't perhaps separate freshmen and sophomores from being at an assembly, a 9th through 12th grade assembly. Everybody's got to show up on time. We're all treated as students, as equals. But deep down, we still have our identity as a sophomore and a freshman. So there are times when, for other reasons not explained in this demo, like when you have an array list that combines all model students, but deep down you have some sophomores and freshmen, like a shopping cart where you have a cold stuff and dry goods in your local grocery store shopping cart. It's all in the same shopping basket, but some of it's from different areas of the store. But to the cash register auto system where you self-checkout, it's all treated the same, and it can be scanned in the same order, in any order. So there are times when you do this, just trust me. What you can't do, and I need to explain before this video ends, is you can't make Matt a model student as an instantiated model student. That's illegal. When I run this variation of the program, we get a nasty, nasty compile error warning us, hey, model student is an abstract class. You can't instantiate or construct or give birth to a true model student. No, the God that may or may not exist doesn't allow you actually to give birth to a true perfect genetic atom. It's like they threw a loop in and something goes with the X's and Y chromosomes and all that. It just is impossible. So you can't do this. Steve Jobs doesn't want you to have a perfect iPhone, but you can have a variation of it. So that would be illegal if you saw that in a multiple choice question on an AP exam with all the code above given to you as part of the exercise. So I'm commenting that out, and I'm showing you something else that's illegal. That's likely to show up on an AP exam or on the job at hulu.com or etsy.com or wherever you might work someday. You can't have Alex do homework. But let's look at Alex closely. It is legal to declare but not instantiate something as a model student. As long as you either just put a semicolon there or explicitly say that it's equal to the keyword null, as long as you do that, you can't then actually execute code that tries to execute a method or make use of instance variables with that reference variable name that you called, in this case, Alex. Watch the error that occurs here when I try to run this program. Now this compiles, but it doesn't execute, and it throws a null pointer exception object as an error, and that is classic no-no, sometimes tested on an AP exam. You just can't do that. Unless you did the new operator and call the constructor, you can't do that. So I'm going to comment that out. And one last thing that I'll say in this video before closing it off. Look, we're calling a default constructor there, but there is no default constructor in the sophomore class, and there is no inherited default constructor in model student. Well, Java gives you a free default constructor, even if one's not explicitly typed out somewhere in your inheritance hierarchy chart. So GPA is equal to 0.0, the default value. Just trust me, it is. We don't make use of it in any interesting way, but it is legal, and there is no error from calling what looks like illegal, unavailable constructors. They do execute behind the scenes. I hope that helped. Here's the version. Here's the website address where you might find a current version of this program. Have a great day, and goodbye.